Welcome, welcome, and welcome again to another DJ Wilson STEM video. All right, so this particular video is a review of the engineering design process for my 8th grade students. Um, you should have been in my class last year in 7th grade, so we're not going to go into the main details or a lot of the details that we went into last year. This is mainly just a review um, to make sure that you remember some of the highlights. For the details, I strongly encourage you to watch the full engineering design process video that was created for you in 7th grade, and also to review your previous notes. All right, so let's do this. So one of the first things I want to do is just remind you that the engineering design process, the definition is a logical method in which to identify problems, then research, design, create, test, and evaluate solutions. Okay, so it's a logical method, which means that it is repeatable, right? It's not just something that based upon my feelings or how things are going today. No, it's a logical method, which means it's repeatable, okay, and it's based upon facts and data. All right. The second is, I like to say, it's a way to create things that solve problems, okay? Remember, as engineers, that's what we do. We find ways to research and create things that solve problems. All right. So we know that the engineering design process is made up of these 8 steps. So identify the problem, research the problem, create solutions, select the best solution, model solution, test the solution, communicate the results, and then continuous improvement. Now, let's get into the details, okay? A little bit more of the high level points. And again, I would encourage you to make sure that you jot down these notes, okay? So, step one, identifying the problem. Now, we need to remember that in identifying the problem, there are various problems, right? Problems don't need to be major, huge issues, but there are, just basic problems. So there's personal problems. Personal problems are, hey, I'm hungry, I'm tired, my shoes untied, stuff like that. Social problems are problems within society. There's too much crime, there's climate change, laws, stuff like that. And then there's technological problems. Technological problems are problems with things that humans created. My cell phone dropped in the water. My computer's not working. All right. And then step number two is once we've identified a problem, we need to look at ways or research um, information about the problem to understand it better. Okay. So this is a way to really, if I've identified a problem, well, how do I know it's a problem? Okay, is it really a problem? So we have to look up at information. So you have to look up the who, the what, where, when, why, and how does this a problem? How does this problem affect people? Okay, who does it affect? What does it do to them? Where is it a problem? When is it a problem? Is it a problem all the time or just sometimes? Why is it a problem? Okay, and how does it affect people? So this is and sometimes you'll spend a lot of the time researching the problem because if you don't truly understand the problem, then you can't always um, get a solution that's going to, or present a solution that's actually going to solve the problem. Okay. Step number three is when we're actually starting to brainstorm ideas or brainstorm potential solutions. So in brainstorming, obviously, we're coming with ideas. We're just putting the ideas out there. We're not trying to make any decisions now. We're just trying to brainstorm ideas. So we write down the solutions, right? And a few things that we want to make sure that we do is we want to make sure that we include how does this solution solve the problem? All right. What does it do? What is it? Defining what that potential solution is. And then also, how does it solve the problem? And then we have to look up pros and cons of that particular solution. So what are some benefits to that solution? How does it work? And then cons would be, are there any setbacks? How does this solution possibly cause problems? So a pro could be for just say if we wanted to build a new car, right? That's a solution. Well, a pro could be that the vehicle it gets people places safer, faster, more efficiently. But a con could be that it uses scarce materials that are hard to find. A con could also be that maybe the vehicle causes pollution. Cons could also be, not everybody might be able to purchase that particular vehicle because it's so expensive, right? So there's pros and cons of each type of solution. Now we also have to look at selecting the best solution. So in step number 4, so step number 1, we identified a potential problem. Step number 2, we research the problem to understand it better. Step number 3, right, we brainstorm. Now step number 4, this is when we're going to be making some decisions. So we have to look at those solutions that we came up with in step number 3, and then we have to make a logical decision based on facts and data about which design to go with or which solution to go with. We don't make, as engineers, we don't make decisions based upon what I think is going to be the best, based upon my feelings or whatever. It needs to be based upon facts and data. So when you're making, in step number 4, this is one of the things that you need to make sure that you're able to do, is write a complete full paragraph, at least a full paragraph, comparing the various solutions that you thought about in step number 3, and then justifying the reason why you're choosing the solution in step number 4. Why are you choosing this solution over the others? Okay, and again, it has to be based upon facts and data. So in 7th grade engineering, we use that whole decision matrix. On the left-hand side, we had the various solutions, and at the top, we had the criteria, and then we rated each solution based upon the criteria, and then that gave us, the best decision or the best solution that we should have gone with. Now, obviously, in 7th grade, you had your choice of whether you wanted to use that particular solution or not that was rated the highest, but you didn't have to, right? But that's typically, if you're using a decision matrix, if the decision matrix is saying you should go with the solution, you probably should go with the solution, but you didn't have to, okay? But in step number 4, this is where that decision is made on why you're going with that decision. Then, step number 5. This is when you're physically creating that solution that you just thought of or that you just made that decision of in step number 4. Now, this needs to be documented. Every step that you take in creating this, the solution needs to be documented. So it needs to be written down, okay? So that if someone were to come behind you and create this solution, right, they would be able to do exactly what you did to make sure that it worked. Step number 6 is testing the solution. And testing your solution, you are testing the solution to determine if it solves the problem. But you're also looking at how much does it solve the problem. So for example, if you're building a solution, right, and so in this year, we're in 8th grade, we're designing rockets that stay in the air the longest using a simple recovery system, right? So when we launch our rockets, right, we're going to have the rockets, the goal is 10 seconds in the air, right? That's the goal. But just say your rocket goes 11 seconds. In the simulation that we're going to use, your rocket stays in the air for 11 seconds, right? Well, you might want to try to get to 20 seconds for your rocket to stay in the air using the simulation software. So how do we do that? How do we get our rocket to stay in the air even longer, right? So, and step number 6, we're evaluating those things. So, did the solution solve the problem? How much did it solve the problem? Okay? And then documenting everything that happened in the test. So, what happened when I launched my rocket? Did it go to the left, right? What happened when we tested this new medicine? Did people get sick first, or did they immediately get better? What happened when I tested my solution? Every part of the test needs to be documented. The reason being is because if you were to do this over, right, and you test it again and you got similar results, well, then maybe something happened, or maybe you did something different in the test. All right. So it's important that you test your solution, and it's understanding that testing the solutions determines if it solves a problem. Step number 7, communicating the solution. Once you've tested your solution, then you're going to communicate it. You're going to include everything that the solution was made of. How much material did you use? What type of material did you use? What was the weight of the material? It also includes blueprints, designs, everything that your solution was made of. And then obviously step number 8 is continuous improvement. Once we've created something, we've tested it, then we look at ways to improve it. So determine methods to improve the solution, and process to create the solution. So there's 2 things here. Not only are you looking at ways to improve the solution, but ways to improve the process of how you did it. So an example of this could be, well, in my rocket, I created my rocket, it went over the 10 seconds, but to improve my solution, I would design it this way. However, improving the process would be, I spent too much time talking with my friends about their solutions, about their designs, or other things in class, but I did not spend enough time evaluating my own or doing my own project. So a way to improve the solution would be to design it this way, but a way to improve my own the process would be for me to make sure that I'm using my time management skills to focus on making sure that I get the project done, or that I complete things, or that I stay focused on doing what I'm supposed to do so I can produce something better. Okay? Now, one of the other things that continuous improvement includes is trade-offs and substitutions. And I want you to make sure that you write these down. Substitutions could be or are using one thing instead of another. Again, substitutions are there's no difference in value or performance. A substitution is, rather than my rocket being red, it's blue. That's a substitution. There's no difference in value or performance. However, a trade-off is using one thing to offset the value or performance of something else. So my rocket, rather than using cardboard, I'm going to use a lighter paper. That's an exchange in value, because I'm using one thing instead of another to try to improve the performance. Okay? So with that, again, just wrap up the engineering design process. It's a logical method in which I identify problems, right? And then research, design, create, test, and evaluate solutions. And again, since it's a cycle, once you get to step number 8, you go back to number 1 to try and design something that's going to perform even better. And it's just you just continue that process to always make something better that's going to solve that solution, that's going to solve that problem even better. All right, any questions? You can't ask a video question. Well, I guess you could ask a video questions, but you're not going to get any answers. All right. So with that, thanks for watching.